I'm going to say that there were W wins, D draws, and L losses. So because I get 3 points for a win, then I would get 3 W points for W wins. So for example, 2 wins would be 3 times 2, 5 wins would be 3 times 5, W wins 3 times 5. And then I get 1 point for every draw, or the team gets 1 point for every draw. So then we're going to add on D. That must equal 80. So I've got an equation here. Now, another equation is the fact that we played 38 games, so it must be that W plus D plus L is 38. So once we've figured out what W and D are, we can work out what L would be. Okay, and then there's another 2 conditions. We won more than twice the number of games we drew. So W must be greater than 2D. That's what that is saying. And also, we won more than 5 times the number of games we lost. So these conditions need to be satisfied. Right, now, if we won 27 games, then we would have had 3 times 27 equals 81 points. So what that is saying is that W must be less than 27. We couldn't have won 27 games or more. However, if we only won like 20 games, so 3 times 20 would give 60 points. And then we'd need to have 20 draws, but we can't have 20 draws because there's only 18 left. We could only get 78 points. So W has got to be greater than 20. Okay, so actually we're well set up with this now. A good shout is just to try these different values. So I'm going to do this here actually. I've got enough space. I've got W, D, and L. Now let's say that W is 21. I'll go up from 20 basically. Then we would get 63 points. And so to get up to 80, we'd need 17 draws. And then this is 38 games already, so there'd be 0 losses. So W is greater than 5 times the number of losses, but it's not greater than twice the number of draws because that would be 34. So we can rule this one out. Let's keep going. So 22 wins, 66 points, 14 draws, and now there would be 2 losses. So again, W is not twice the number of draws. All right, let's keep going. 23. Then that would give 69 points. It'd be 11 draws. This one is more than twice the number of draws. And we're on 34, so there'll be 4 losses. And 23 is more than 5 times the number of losses. So this is looking very good. Okay, we probably shouldn't stop there, although we're probably maybe thinking the answer's got to be 11. Let's just check there are no more solutions. So 24 would get me 24 times 3 is going to be 72, so I'd need 8 draws. So the number of wins is more than twice the number of draws. Okay, we're kind of in that territory now, but what about the number of losses? We've got 6. So now we've got 4 times the number of wins as losses. That doesn't actually work, and you can kind of see now that the number of losses is going up, the number of wins is going up, but the losses are going up faster. So here I'm going to have 75. There'll be 5 of these. There'll be 8. So that's not going to work, and 26 isn't going to work for a similar reason. Okay, so it must be that we have 23 wins, 11 draws, and 4 losses. I like this question. I always like these kind of Diophantine equations, essentially. We've got integer solutions to these equations, different restrictions going on, and we can just work our way through it. Sometimes there's like methods that help you speed it up. We kind of use that here, just the endpoints, and then cycled through it to get the different answers, only one of which satisfies these two.